Welcome to another secondary snack. My name's Christina Turner and I'm a lead maths specialist for White Rose Maths. Today we're going to be talking about developing number sense. So here you can see the small steps for the block developing number sense. This is aimed at Year 7 students and it's generally taught in the second half of the summer term. So why are we focusing on developing number sense with Year 7 students? Well, I'm sure that you've seen that students often go firstly to a written calculation when we ask them to calculate something like 17 subtract 9. And you can see here that the column method is completely useless. So what we want them to do is to develop a toolkit of strategies so that they can mentally add, subtract, multiply and divide with confidence. So today we're going to be focusing on this small step, and in particular we're going to be looking at multiplication. So here's the notes and guidance page for mental multiplication and division. And the key vocabulary here is going to be really important. We want the students to be able to discuss different methods. We want them to be able to compare them, but without language such as partitioning or commutative, that can be quite difficult. So language is definitely something that we need to emphasize in this small step. And if we have a look at this exemplar question, you can see that it focuses straight away on the method, the strategy, and not on the answer. So Tommy knows that he needs to work out 18 multiplied by 5, and the students are given 4 different strategies for that calculation. And the premium resource follows on with this. So again, is focusing on the method and not the answer. The students are given a method for working out 99 multiplied by 7 mentally. So multiply it by 100 and then subtract 7. Now, to us, that might seem obvious as a strategy, but for students, that can sometimes seem quite abstract. So you might want to support this using the area model. Here we have 100 multiplied by 7, and we're going to cut off the end bit here. We're going to cut off 1 multiplied by 7. If we do that, what are we going to be left with? Well, if we subtract 1 multiplied by 7, then I've now got 99 sevens. Now, if I've subtracted 7, we know that 99 multiplied by 7 must be equal to 693. And that just makes the thinking around the strategy very clear for the students. Let's look at another calculation, 28 multiplied by 5. Now again, a lot of students will go directly to a written method. Here are some. Now there's nothing wrong with these written methods, and in this case all of the students have got them correct. However, they are definitely prone to error and they're not always the most efficient way. So if we have a look at that repeated addition, that's not the most efficient way of calculating 28 multiplied by 5. We want the students to be able to efficiently do that by mentally calculating. If we consider this written method for 28 multiplied by 5, we can see that it links directly to the mental method of partitioning. So the idea that we could calculate 28 multiplied by 5 mentally by partitioning the 28 into 20 and 8 and multiplying the 20 by 5 and then the 8 by 5. And it can be useful for students to see those links between the written method and the mental method. And of course, we can also justify that method by using the area model. So we can see that the 28 has been partitioned into 20 and 8, and then we've multiplied the 20 by 5 and then the 8 by 5. We can take this a step further. We know that 28 multiplied by 5 is equal to 5 multiplied by 28 due to commutativity. So we know that 5 multiplied by 28 can be expressed as 5 multiplied by brackets 20 add 8, just partitioning the 20 and 8 again. And that's equal to 5 multiplied by 20, as we can see on the area model, add 5 multiplied by 8. And of course, this links to algebraic thinking. And we want students to be able to mentally expand those brackets, mentally multiply those out. It gives them a tool for doing this, and they can see it again on the area model. So another strategy for mentally calculating 28 multiplied by 5 is to think of it as 30 multiplied by 5 and then subtract 2 multiplied by 5. And again, you can see this on the area model. So we know 28 multiplied by 5 is equal to 5 multiplied by 28 due to commutativity. So we know that it's the same as 5 multiplied by, in brackets, 30 subtract 2. And you can see the expansion of that there as well. And of course now that links to algebraic thinking again, but this time we have a negative in the bracket. So what other strategies are there for mentally calculating 28 multiplied by 5? Well, a really lovely one is the halving and doubling. So 28 multiplied by 5 is equal to 14 multiplied by 10. Or perhaps thinking about multiplication by 5 is the same as multiplying by 10 and then dividing by 2. Both really good strategies. And of course, we could use some kind of diagram to support that thinking. So you might want to pause the video now and just think about how you could perhaps use that diagram to support the justification of both of those mental strategies. We can also consider developing number sense when multiplying a 2-digit number by a 2-digit number. So here we have a fact: 38 multiplied by 42 is equal to 1,596. And we're going to ask a question around this fact. The question is this: which is greater, 39 multiplied by 42 or 38 multiplied by 43? Quite a tough one to think about without a diagram. So I'd certainly suggest asking students to draw a diagram so that they can justify their answer, and that really helps support their thinking around this question. In fact, you might want to just pause the video now to think about how you would do it. Now, some students might go straight to a written method there and calculate 39 multiplied by 42 and then 38 multiplied by 43. But actually, in this case, that's really inefficient, and we really want them to think about it in a different way, and we really want them to develop that number sense. And I think it's the diagram that helps them on that journey. So here we have 38 multiplied by 42. So that's what we started with. We started with the fact. And if we think about 39 multiplied by 42, we can see that we're adding on another 42. We've got 39 of them instead of 38 of them. When we think about 38 multiplied by 43, well, this time we're adding on another 38, because instead of having 42 lots of 38, we've got 43 lots of 38. So we can clearly see from the diagram that 39 multiplied by 42 is greater. And we can ask more questions around this fact. So, true or false, 38 multiplied by 42 is equal to 40 multiplied by 40. So students with good number sense will spot straight away that the last digit of the answer to 38 multiplied by 42 must be a 6, obviously 8 multiplied by 2, whereas the last digit in the answer to 40 multiplied by 40 must be a 0. So it's definitely got to be false. But for some students, it would be helpful for them to draw a diagram to justify their answer so that they don't directly go to a written method, which some students still will, which of course we know is inefficient. So again, just something that you could trial in the classroom. And finally, getting the students to discuss their strategies, to compare them and to work out which is the most efficient is super important in this small step. So you might want to give the students some information such as this and get them to discuss why each method works, and perhaps to add their own methods. So you can see the first one, 42 multiplied by 3, and 2 different strategies. The second one, 42 multiplied by 50. So is it easier to multiply by 5 and multiply by 10, or to multiply by 100 and divide by 2? And the last one, 42 multiplied by 25, the idea that multiplying by 25 is the same as multiplying by 100 and dividing by 2 and dividing by 2 again. And of course, they could add their own strategies too. So to conclude, here are the key points from this small stack. Firstly, model a variety of strategies and make sure you're using diagrams to justify these so the students really have an understanding of them. Of course, encourage discussion and reasoning, and compare methods for efficiency. That's what we're really after here. And finally, where possible, make links between the mental and written methods and algebraic thinking. I hope you've enjoyed today's secondary snack, and I hope there's something that you can take immediately into your lessons. Thanks very much. Bye.